Okay, girls, welcome back. So we are going to continue from the file acid, alkali, and titration. So very first thing that we are going to do today is about indicators. Any idea before if you know or if you have ever studied about indicators? What is an indicator? Where we use them? Any idea?
Miss,
Yes.
may I?
Yes, Luna.
Luna. Miss, I we learned about the indicators. We learned about that it is used to identify whether the substance is either an acid or an alkaline.
Right.
That's one of the things that we
So for
studied
the
about it.
indication of acid and alkali, right? Yes, Samreen.
Yes.
Yes, miss, like it is used to identify the substance whether it is acid or alkaline. An example
Right.
is also
Hmm.
litmus paper.
Litmus paper is one of the example, yes. So we can use any substance, any material, any paper to identify acid and alkali. So that is basically telling us the indication. So we say them indicators. Yes, Luna.
Miss. Also, we have another example to know about the pH values. We use
Hmm.
I remember a table full of colors, and then the
Hmm.
pH 7, which is neutral. It's usually in a bit of a green color.
Right.
And
So,
then the for the alkali, the darker there
hmm.
you go, like blue and purple. This one's for the alkali. I remember, and for the acid there are I remember red and orange and a
Hmm.
bit of yellow. You know
Yes,
the
very good. So that's a good summary. So basically, indicators can tell us in the value of acid and alkali, or they can identify the acid and alkali in two different ways. They can tell us about the pH values, or they can tell us about the colors. And we have a whole graph, you can say, about the colors, and we can match the color if you're getting red color, violet color, purple, green. It is the neutral range or the acidic range or the alkali range. So like this we can identify. So yes, that's the perfect basic introduction you guys already have. So let's see a little more detail about the indicators. So every indicator is basically telling you about two colors. One color it will give you in acid and one color it will give you in alkali. And one of the common indicator that you have already studied is about litmus. Litmus is one of the common indicator. Litmus we can use in the form of solution as well, or we can use in the form of paper as well. So we say it litmus paper or pH paper. So it can be solution, it can be a paper. Both will be known as litmus. Litmus is one of the indicator which is basically extracted from or it is taken from a plant called, it is taken from lichens basically. Okay. So many of the indicators are taken from the plants because plants have some substances inside which can change the color according to the pH value, according to the acidic and alkali environment. There are many plants, you can even search them on Google as well. You will see some flowers and some plants. If the soil is acidic, the flower color will be different. If the soil is neutral, the same plant will give you the flower color different. If the soil will be alkali, the same plant is giving you a different color flower. So flower color is changing according to the pH of the soil. So like this, the plants are basically the perfect and best indicators to identify the acid and alkalis. Okay, so most of the indicators are synthetic, means we can prepare them as well in the lab. And synthetic indicators are prepared from some organic compounds. We'll talk about organic compounds in our coming topics next week. So organic compounds are basically very sensitive to changes in acidity, means if we change the pH value towards acidic or towards alkali, so the organic compounds are very sensitive to these changes. They can give us different colors according to the pH values. Okay, commonly used indicators are three. Litmus, which you already know. Two will be new for you, phenolphthalein and methyl orange. Their color change you have to remember. Litmus is giving you the color red in acid, blue in alkali. Phenolphthalein gives you colorless in acid, pink in alkali. Methyl orange will be red in acid and yellow in alkali. So their names and their color change in acid and alkali you need to remember. Okay, yes, Luna.
Miss, I have a question.
Hmm.
If it was water, which is usually does not have a pH or has a pH value
Hmm.
7, if you put these substances, what color would it be?
Then it will
Like,
be a different color. Okay, then it will be different color. That is not here needed to remember, but then it will be a third color. Okay.
okay,
In
okay,
neutral
thank you.
solution, it will give you different color. Acid and alkali, different color. So if we are doing the titration, we basically need only the acid and alkali color to remember. Okay. So like this, we can have the color. In neutral, definitely they are giving you a different color. For like most of the time, neutral solution give you a green color. So we can remember this way. Okay. So why we use these synthetic indicators or any indicator, basically they are giving you a color change. But it is important that if we are using or choosing any indicator, we need a sharp change in color. Okay, we need a sharp change in color. It means if it is giving you one color in acid and other color in alkali, that color should be completely different from each other. If they will be little similar color, then we will not be able to identify the change in color easily. For example, if we choose litmus as an indicator, litmus solution as an indicator, it is not suitable, like it is not a good indicator. Why? Because it gives you purple color in case of the neutral solution. And if you check over here, it is giving you blue color in case of the alkali solution. So color change from purple to blue or blue to purple is basically difficult to identify. Like it will look somehow similar. When it is changing, we will not be able to identify when it is transitioning or changing from purple to blue or blue back to purple. It will take time to identify the color change. So in that case, the litmus solution is not a suitable indicator most of the time. Okay, because the reason is because its color change is not having a big difference. It's close to each other, so we cannot use this kind of the indicator. Yes, Luna.
Miss, what does it mean by titration?
Uh, Titration? Yes,
Yes.
titration we are doing today. Then you will be able to identify it's a method where we are mixing acid and alkali together and changing the color to find the concentration. So we will be doing today, then you will be able to see how we can perform it. So we
Okay,
use
Miss.
these indicators basically in titration method. So litmus is not a good indicator because it is not telling us a good transition in color or change in color when we have neutral solution or alkali solution like this. But if we want to use any other indicator, we can use litmus paper. Litmus paper is a good indicator in that case because paper is telling you only two colors, red and blue. So that will be okay to easily check the litmus paper. We can dip into the solution, see it's red or blue. Red means it will be acid, blue means it will be the alkali. Okay. So same way we can use this litmus paper for testing the gases as well. We said the gases test already, where we can just put the litmus paper in front of the mouth of the test tube from where the gas is escaping and see the color change. Okay. After that, pH scale. Who can just quickly tell me the pH scale, the values, when it is going to be acid and alkali, and in acid range, what do you know about 1 to 7? Like 1 means which type of the acid, 7 means which type of the acid, anything you know about this? Okay, so we have Luna. Anyone else who want to participate? Luna and Samreen. Okay, Samreen, you will tell me all about acid, and Luna, you will tell me about alkali. Yes, Samreen.
So Miss, acids have a pH low than below 7. So like the highest pH of acid can be 1.
Highest pH can be 1. Okay. Okay. About the alkali? Yes, Luna.
Miss, yes, for alkali, the higher the number, the more alkali the solution is. So basically, since we take it from 0 to 14, number 14 is the most alkaline solution, the strongest one, you can say.
Right. Yes, Alina, you want to add something? in any of the point about acid and alkali?
No, not really. I wanted to say the same thing. And like seven's neutral.
Okay. Yes, Maria Mahmood, anything you want to add here?
Miss, I was going to say the same, but in acids they have a bitter taste, and alkalis they have a sour taste.
Okay,
That's it.
right. Okay, I will add one thing here. Okay, all the points are fine basically that you guys said. About the acid, it's not only from 1 to 7, it's basically from 0 to 7. 0 will come in the range as well. Like acid can have pH 0.1, 0.2, 0.5 like this as well. Like less than 1 pH is also possible for acid. And 0, closer to the number 0 means it's stronger acid. We have this pH scale. It's from 0, then 7 will come in between, then till 14. 0, 7, 14. So this range is acidic range. This range is alkali. And at the 7, it is going to be neutral. Okay. So if it is close to the neutral, it is weak. Away from the neutral, it is strong. So just remember this. This range which is close to the neutral, it is weak basically. So if acid is close to the 7 pH, it means it is weak acid. Like 5, 4, 6, 7, near to 7, these pH values for the acid means the acid is weak. Away from this range means that is going to be strong acid. So here it is going to be strong acid with the pH that they said you the range over here. pH between 0 to 3 is going to be strong acid. Above 3, 4 to 6 or 6.5, 6.7 this way as well. Near to 7, all are going to be weak. Same for alkali. Alkali close to 7 is weak, away from 7 is strong. Close to 7 means 8, 9, 10. These pH for the alkali, they are weak. But near to the 14, alkali is going to be the strong alkali. And both the corners are strongest. This corner alkali 14 is the strong alkali, strongest alkali. This corner 0 or near to 0 pH value for the acid is going to be strongest acid. Okay. So, and the 7 is basically a neutral. So this, like this, you can remember this pH scale starting from 0 till 14. Any question here? We have few students raising the hand. Yes, Luna. And Mariam, you have any question here?
Miss, sulfuric acid is the most
Oh no,
strongest.
miss, I just opened my hand
Sulfuric
for
acid.
answering.
Okay. Yes, Mariam, sulfuric acid is the strongest acid as well. One of the strongest acid. We have
Zero?
many acids which are strongest. So sulfuric acid is also one of the strongest acid. That's a good point.
It has 0 pH.
With pH, what you said?
Sulfuric acid have 0 pH.
No, not 0 exactly. Close to 0. It's close to 1 basically.
Okay.
Okay, not exactly 0. It's close to 1 pH for the sulfuric acid. Hydrochloric acid is also a strong acid. It also has a pH close to 1. Okay. Okay, let's move forward. After that, we have an other indicator as well. 3 of them we already did. Litmus, phenolphthalein, methyl orange. One more that you can remember is universal indicator. Universal indicator is basically different from all the 3 previous indicators. Okay. So this indicator is basically telling you a wide range of colors, not only one color for acid, one color for alkali. It is giving you mixed colors for each pH value. So telling us a range of colors. So this indicator, how we can make it? It is basically made from different plant indicators mixed together so that we can have a broad pH range. And we can easily identify the pH of unknown solution. For example, we have universal indicator paper. We can take the paper and we can dip in the solution. It will give you a color change. And then we can take a chart of the color. Chart will be given to you where you can match the color back and see what is the pH value exactly. Not only you can identify acid and alkali, but you can identify is it weak acid, strong acid, or what is the pH value exactly. Here is a chart that I will show you. Let's say you have a solution. You are going to dip the paper in the solution, universal indicator paper. We know that red color or somehow near to red is acid. Violet blue is going to be alkali. Green or near to green is going to be neutral. Fine. but we want exact pH. So brown means it is 0 pH. Red means it is 1. Like this, you can keep going till number 14. So whatever color you are getting, let's say you want to check the pH of water, take the paper, dip in the water, and then just come back and match with the chart and see what exactly is the pH of water. The normal drinking water, if you take, you are going to dip it, you will get the pH not green. You may see the color dark green a little. Why? Because the water that we drink most of the time is slightly alkaline. It's a little alkaline solution, not exactly neutral. So you may get a pH more than 7, near to 8. So like this, universal indicator is telling us a wide range of pH values. Yes, Mariam, any question here?
No,
Miss,
Miss, I forgot to lower my hands.
Okay.
Miss, I have a question.
Yes, Luna.
Why is pink considered as acidic, not like alkaline? Because it's closer to the colors, violet and purple. Miss. You
Here,
get what I mean?
basically, it is getting lighter. So it will be red, then little pink, then orange this way. Here it is getting darker, from dark blue to dark blue, then violet. The violet should be little darker here, not exactly like the pink. Color is little different here. Then it will be very dark purple. Okay. So this pink and this violet maybe look similar to you, but that's different. Pink will be little different color and this violet will be little different. Okay. And this chart is not same for all the companies. Let's say some companies are making this universal indicator paper. Their color scheme can be little different as well, depending upon what material they're using to make the paper. So for this reason, whatever indicator paper you are using, they will give you the color chart. So for universal indicator, whatever person is going to manufacture it, the manufacturer, they always provide you the color chart. And you can just dip the solution, see the color change, and then you can come back and match it to get the exact value. Okay. So that's all about the universal indicator. Okay. Now, if I ask you, can we use this kind of the universal indicator in acid-base titration or no? We are going to do the titration, then we will come back to this point and that will be more clear to you that universal indicator we cannot use in acid-base titration. Because in acid-base titration, we don't want to see the pH. We just want to see, is it something acid or alkali? That's it. Something is changing from acid to alkali or alkali back to acid. So in that case, we are not using universal indicator. We are using simple indicators to see the sharp color change, only one color change, not the 14 colors. So let's move to the titration. Then this point will be clear to you and we will come back to this point and see it again. Okay. So for the titrations, before the titrations here, we have a quick introduction of acid and alkali again. Who can quickly tell me, as we did already, what is acid, what is alkali, which ion is present in acid, which is giving it acidic nature, which ion is present in alkali, which is giving it alkaline nature. Okay, so we have Mariam, Luna, and Samreen. Anyone else who want to participate in discussion? Which ion is present in acid? Which ion is present in alkali? Okay, Mariam.
Miss, I will say both of them.
Yes, both of them for acid and alkali. Yes, Mariam.
Okay, so acids, when we put them in water, they give off positive hydrogen ions,
Hmm.
and this what makes them acidic. And alkalis, when you put them in water, they give off negative hydroxide ions, and this is what makes them alkaline.
Right, that is fine. So acid is telling us about the hydrogen ions presence. So because of the hydrogen ion, the solution is becoming acidic. Alkali, when added to the water, they give us the hydroxide ions, and because of the hydroxide ions, they are giving us the alkaline solution. Okay, then we have definition of the pH as well. For the pH, here I will tell you one thing which is basically not exactly your syllabus for now. You will do this in grade 11. The word P means this small p basically that we use, it is negative log. Have you done the negative log in maths? Negative log or any log value. You know how to take the log on the calculator.
Nope. we're just learning sin, tan, and cos this year, so
Okay, fine. So there is a button in the
I think it's
calculator
in
as well.
AS.
Right. So P means negative log. So we are not doing P is basically telling you the concentration of hydrogen here. P means negative log. H means hydrogen ion concentration. So ignore P for now because it is not in your syllabus for now. You will do this later. So P basically used for the negative log. H means for hydrogen ion concentration. It means pH is telling you how much hydrogen ion is present. Okay. pH number is telling you how much hydrogen ion concentration is there. So if they ask you what is the definition of pH scale, so pH scale is basically measurement of hydrogen ion presence in the solution. Because pH is just telling you how much hydrogen is there. If hydrogen ion concentration is more, means it is acidic. If hydrogen concentration is less, OH is more, means it is alkali. So remember over here that if H positive ion concentration and OH negative is same in any solution, means that solution is neutral. In any solution, both are there. Even in the acidic solution, both are there. In alkaline solution, both are there. But when they both are equal, it is known as neutral solution. When H positive ions are more than OH negative ions, then it is going to be acidic. Okay. And when H positive ions will be less and OH ions will be overall more, then it will be known as alkaline solution. Both are there in the solution. Why both are there? Because water is there. We said aqueous solution of acid, aqueous solution of alkali. So aqueous water means HOH, both are there in the solution because water is providing both ions. So when both are same, that is neutral solution. When H concentration is more, H ions are more, then it is acidic. When OH ions are more, then it is alkali. So pH scale is telling you how much hydrogen ions are there. Hydrogen more means acidic, hydrogen less means alkaline solution. So that's how we can put the pH value. Yes, Luna.
if the acid it's pure acid and it's not mixed with water at all, it does not like have any water, it's just pure acid, how can we find out like by
It is still having H and OH because acid is in the form of solution always. Okay.
So it's always mixed
Example
by
for
water.
sodium hydroxide. Sodium hydroxide is present in solid form, solid pieces. But when we are using in the solution, we are using in the liquid form means that is mixed with water already.
Okay.
So same way, all the acid alkali solutions already have some water inside, but we can make it more diluted by mixing more water. But already HOH is there in all acid and alkali solutions. Okay. Okay, after that, let's move towards the neutralization reactions. Neutralization reactions, we know when we mix just the acid and alkali together, means acid is giving you H, alkali is giving you OH. H and OH can mix together and they can make water with the pH 7. So solution is going to be neutral in that case. So whenever acid alkali mix, it is going to give you neutral solution. But not all the reactions are neutral. And one of the example we did was the metal with acid. When simple metal, not base, simple metal is not base or alkali. When simple metal was reacting with acid, it was producing a salt, but not water. So in that case, it was not a neutral reaction. When acid was reacting with metal oxide, metal hydroxide, metal carbonate, these three were bases. So in that case, it was neutralization reaction. But when acid was reacting with simple metal, metal is not alkali or base. So in that case, it was not a neutralization reaction. Okay, so here is one of the neutralization example about acid and base reacting together to make water and salt. Water H is coming from acid, OH is coming from base. For the salt, Na is coming from the base and Cl is coming from the acid. So like this, the reaction will happen. But here, yes, Luna.
Miss, why in the reaction HO why is it written HOH, not H2O?
No, it's just for your convenience to tell you how they are basically from where they are coming. But when
Oh,
you will
okay.
be writing chemical equation, you will write H2O. Here they're just telling you from where this H is coming and from where this OH is coming. But in actual equation, you will always write H2O, this form. Okay?
Okay, Miss.
Okay, after that, this is the main neutralization reaction. But we can also divide this reaction into two separate equations, two individual reactions. Okay. For example, this one which is making water, that H from the acid, OH from the water, from the base is making water. So this is one equation. Then Cl from the acid means the non-metal negative ion, and Na positive from the base is making NaCl. So like this, we can write two equations as well. We have already done the ionic equation. You know about the ionic equations and how we can split the aqueous things and we can cut them and we can just remove the spectator ions, right? So here we can do the same thing, that we can just split them into ions and we can just cut them so we can get the ionic equation final. So final ionic equation, remember as a trick. No need to cut it, write it every time. Just remember the net ionic equation or the final ionic equation of all the acid-base reactions is going to be same. It is going to be H positive, OH negative is giving you water. Always. Okay. How? I can just tell you one example over here and that is going to be applicable for all cases. HCl over here is aqueous. NaH over here is aqueous. Water over here is going to be liquid. Water over here is going to be liquid. NaCl produced in the solution is also aqueous because it is a soluble salt. Okay, you can split them into ions, right? Can you tell me the ions for HCl? HCl having? Yes.
H and Cl, the
H
hydrogen
positive and Cl negative ions. Both
negative,
will be
yes.
aqueous as well. NaOH is going to split into
Na
Na
positive plus OH
That's
negative.
mine.
and then water will remain as it is, H2O liquid. Then NaCl will split into
Na positive
Na plus Cl minus, right?
plus Cl
right.
minus. Yeah.
Don't forget to write aqueous with all these ions. Even after making these ions, you have to write the symbol AQ with all. Okay, now we can cut the same ions on both sides, right? So which ions we can cut, which are basically spectator ions on both sides of the equation?
Miss, I don't understand. What do you mean by cut? Like
Okay, I will
divide?
tell
I
you.
understood it by dividing.
Okay, first of all,
But
tell
what
me which ions are same that we can cancel on both sides.
Miss Sodium, right? Sodium and chlorine.
Sodium and
Chlorine.
chlorine. Okay, these ions we can cancel. Now, what ions are left? H
water?
positive aqueous, OH negative aqueous, right?
Yes.
And on product side, we have water. So you will just take them and you will write this equation over here. H positive aqueous, OH negative aqueous is giving you H2O liquid. So this is going to be your ionic equation. And those ions that you are cancelling on both sides, which are same, they are known as, remember this one, they are known as spectator ions. And what does mean by spectator ions? Means they are not participating. They are not participating in this ionic reaction, ionic equation. Because they're same on both sides, so they will just cancel out from the reactant product side. Okay?
Miss,
We
Miss,
will
you
write
mean
main equation.
Miss,
Yes, Mariam.
you mean that they are not participating in the neutralization reaction?
Yes, they are not participating in the ionic equation reaction.
Miss, but how they are not participating in the ionic?
Why they're not participating? See, they were present in the reactant side and they are same to same present in the product side. Means they are not changing into anything new. Whatever they were in the reactant, same they are in the product.
Ion. They form ionic
No,
bond.
they dissolve, they are making ions, but they are not making something different. For example, here the H positive and OH negative ion is making something new, water, liquid. They are joining together to make something new, water, liquid
But
here.
this, they will also join together to make NaCl.
No. See, over here. They are making water liquid in a new state. Liquid. Before it was aqueous, now it is liquid. But for the spectator ions, they were before aqueous means dissolved in water. After that, their NaCl means aqueous again dissolved in water. State
So
is
they
not
don't form
changing. They are
something
still
new.
in the form of same ions in the solution. Before they were Na and Cl ions, after they are still Na and Cl negative ions. They are not making anything new state.
Okay.
So in other words, they are in the solution before, they are in the solution after. They are not making anything new. So we can say they are spectator ions. They are not participating in the reaction. But for H positive and OH negative ions, they are participating to make something new, water, with a new state, liquid. Okay. So liquid cannot make over here ions, but the aqueous state can make ions. Then just split them into ions, cancel out the same on both sides, which are spectator ions. And the remaining ions are going to make the net ionic equation or final ionic equation over here. Okay, I hope this is clear to everyone. Is there any question? Yes, Samreen.
So, miss, if they change their states, they are not spectacular, right?
If they are changing the state, they're not changing the state, then they're non-spectator, or you can say no name for them. We have only spectator ions, which are basically same on both sides with same state, and we can cancel them.
Okay, miss. And miss, another question that you were saying that the neutralization reaction, they are not applicable when metal reacts with acid. So,
Yes.
miss, it is because the water is not formed.
Because the water is not formed. We need water for neutralization reaction with pH 7 value. If water is
And
not
the
formed,
pH is also not
that
7.
reaction,
pH is also not 7.
pH will also not 7, yes. We still need water only then it will be known as neutralization reaction. If water is not forming in the product side, that reaction is not a neutralization reaction.
Okay, miss.
Okay. Okay. After that, why we are talking about these neutralization reactions? They are very important. Most of these reactions are important basically for the soil. Let's say if you are going to check the soil, you want to grow some plants. First of all, you will see that the soil is suitable or no. You are just putting the litmus paper or universal indicator paper into the soil to see the pH value of the soil. You can check the soil, mix with the water, make a solution. Check the pH and see what is the pH of the soil. Let's say the soil is very acidic. That will not be good for the plants or crops to grow because most of the crops cannot grow better in the acidic pH. They may need neutral pH, or most of the plants need alkaline
Miss,
pH to grow or
but
neutral
but
pH to grow. Yes,
miss,
Luna.
you were you were starting the class by saying that the plants can grow in acidic, so they changed their colors. Those are
Yes.
some rare.
Not all. Some plants grow in acidic condition. Some plants grow in neutral condition. Some plants grow in alkaline condition as well. So
But
it
most of
depends
them in neutral.
most of the time they need neutral pH as well. It depends whatever plant you want to grow. So let's say you are growing a plant which needs a neutral soil, but you have a soil which is acidic. So how you can change the acidic soil to neutral soil so that the plants can grow? For this, you need to know this concept. First of all, what is neutralization reaction? How you can change any idea from your side if you have acidic pH, but you are growing a plant which needs a neutral pH, what you will do with the soil?
Add
Yes,
alkaline substances.
add any alkali in the soil. Because soil is acidic, you are going to add something alkaline in the soil. Acid alkali will react, make water, means neutralization reaction. Soil will become neutral.
Oh
Okay?
yes, miss, and it's also very moisturizing for the plants, as water is very needed for the plants. So
Right. So we can add in that case to the soil any base or alkali. For example, limestone, quick lime, any base we can take that is good for the plants as well. So we can add to the soil, soil will become neutral and plants can grow better. Those plants which need neutral soil. So like this neutralization reaction is important for the plants.